Hey everyone, I hope you're doing well today. In this video, let's simplify down the process of solving equations with one variable. As you can see on the screen, I'm going to go through these 39 practice problems from beginning to end. We'll start off by solving some one-step equations, then we'll try some two-step equations. Here's an equation where you have to combine like terms first. Then we have some equations where we have to use the distributive property first. We'll practice solving some equations where we have variables on both sides of the equation. Then practice solving some equations that have variables on both sides of the equation and the distributive property. And finally, at the end, we'll work on solving some equations that have fractions in them. These equations are just proportions, so we can go ahead and solve them by using cross products or equivalent ratios. I encourage you to grab some paper and something to write with and try some of these on your own before I go over how to solve them. Whether you do them with me or just want to watch, let's go ahead and do some math together. For question 1, we have the equation m plus 12 is equal to 10, so we're going to solve for m, and we see this plus 12 on the same side of the equation. So to solve for m, we just have to do the opposite operation and subtract 12 from both sides of the equation. When we do so, that positive 12 and minus 12 will cancel out, so we just have m, or m plus 0. I'm not going to go ahead and write that 0 right now, and on the right side, 10 minus 12 is going to equal negative 2. Just like that, that would be the solution to this equation. For number 2, we have negative 2 is equal to g minus 9. So when you take a look at this, we're solving for g, and with it we have a minus 9 on the same side, so the opposite of that is going to be writing plus 9 on both sides of the equation. When we go ahead and do that, on the left side, negative 2 plus 9 is going to equal positive 7, and on the right side we're just left with g, since that minus 9 and plus 9 cancel out. We can just say that 7 is equal to g, or g is equal to 7. Either one is fine. For number 3, we have the equation negative 7 times y is equal to negative 91. So again, there's a multiplication here. So we have this minus 7 or negative 7 multiplied by the y. So to undo that or use the inverse operation, we're going to go ahead and divide both sides by negative 7. On the left side, negative 7 divided by negative 7 is going to be positive 1 or 1y. I'm just going to write y. And on the right side, negative 91 divided by negative 7 is going to equal positive 13, since a negative divided by a negative is a positive. There's our solution. For number 4, we have the equation a over 9, or a divided by 9, is equal to negative 4. So to solve for this a, we have to see this divided by 9 on the left side, and what we're going to do is we're going to go ahead and multiply both sides by 9. So on the left side we'll multiply by 9, and on the right side we'll multiply by 9. The 9 and 9 are going to cross cancel on the left side, and we're just going to be left with 1a, or a, and on the right side, negative 4 times 9 is going to equal negative 36. Since a negative times a positive is always equal to a negative. For number 5, we have 2/3 of x, or 2/3 times x, is equal to 10. So to go ahead and solve these types of equations where we have a fraction coefficient, we have this 2/3 that's being multiplied by x. Try to remember how reciprocals work. So if you were to multiply a fraction by its reciprocal, you always get 1. So on both sides of the equation, let's multiply it by 3 over 2. On the left side, the 3 over 2 times 2 over 3 are going to cross cancel, so we're just left with 1x, or x. And on the right side, what you're going to see is this 10 is really 10 over 1, and this 2 and 10 are going to cross cancel to make 5 and 1. So 5 times 3 on the right is going to be 15 over 1, so we can say that x is equal to 15. For number 6, we have a similar equation to number 5, where we have 4/9 times w is equal to negative 8. So remember, this 4/9 that's in front of the w is being multiplied by it, and we really want a coefficient of 1. So just like the last problem, we can go ahead and multiply the left side by 9/4, the reciprocal, and multiply the right side by 9/4 as well. On the left side, 9/4 times 4/9 is just going to be 1, or 1w. I'm just going to go ahead and write w here. And on the right side, this negative 8 is really negative 8 over 1. And we can go ahead and cross cancel this 4 and the negative 8. That'll become a negative 2. And so negative 2 times 9 is going to be negative 18. So w is equal to negative 18. That would be our solution here. For number 7, we have the equation negative 6/5 times k is equal to 12. It's really similar to 5 and 6. We just have a negative coefficient for k instead. So we have this negative 6/5 multiplying by the k. And to get rid of that negative 6/5, what we're going to do is we're going to go ahead and just multiply the left side of the equation by negative 5/6. Make sure it's a negative, because a negative times a negative is a positive. And on the right side, we're going to also multiply by negative 5/6 as well. So on the left side, those fractions, the reciprocals, will cross cancel. We're just left with 1, or 1k. I'm just going to write k on the left side. And on the right side, 12 as a fraction is going to be 12 over 1. that 12 and 6 can cross cancel to make 1 and 2, since 6 goes into 12 2 times. And that 2 times that negative 5 is going to equal negative 10. So k equals negative 10 would be the solution to this equation. For number 8, we have a similar one to number 7, where we have negative 1/2 times m is equal to 9. So looking at this negative 1/2 as our coefficient for m, again, we want a coefficient of positive 1 to solve the equation. So let's go ahead and multiply the left side by negative 2 over 1. And on the right side, let's multiply that by negative 2 over 1 as well. So on the left side, those reciprocals will cancel out to make 1m, or just m. I'm going to go ahead and write that on the left side. And on the right side, negative 9 as a fraction is just negative 9 over 1. Doesn't really matter though, since both of those numbers have a 1 on the bottom. And negative 9 times negative 2 is going to equal a positive 18. So m equals positive 18 would be the solution to that equation. Hopefully you noticed that for all 8 of these examples, the goal is really just to get the coefficient of the variable to be positive 1 and to have no other numbers on the same side as the variable. In number 9, we start having equations where we have 2 steps instead of 1. And what makes them 2-step equations is the fact that they have 2 operations. So when we have these types of equations, we're going to go ahead and take a look at the addition, subtraction, and undo those first, and then deal with the multiplication and division second. So for this first one, to undo the plus 8, let's go ahead and subtract 8 from both sides of the equation. You're going to notice that that plus 8 and minus 8 cancels out on the left side to make 0. I'm not going to write 6x plus 0, I'll just write 6x. And on the right side, 50 minus 8 is going to equal 42. So it was a 2-step equation, and now it is a 1-step equation. So on the left side, we have a coefficient of 6. We have 6 times x. But remember, we want a coefficient of 1, not 6. So let's go ahead and divide both sides by 6. That's an inverse operation. 6 divided by 6 is 1, so we have 1x, but I'm not going to write the 1 right now. So we just have x is equal to, and 42 divided by 6 is equal to 7. So there we have our solution for this equation. For number 10, we have the equation 2n minus 5 is equal to 11. So again, let's undo the subtraction here. So this minus 5, to undo that, the inverse is going to be adding 5. So let's go ahead and do that to both sides of the equation. And so if we add 5 to both sides, we have just 2n on the left side plus 0, but I'm not going to write it. And on the right side, 11 plus 5 is equal to 16. So let's solve for n, but our coefficient is 2, so this is 2 times n, right? And so to get a coefficient of 1, to just have 1n alone, let's go ahead and divide both sides by this positive 2. 2 divided by 2 is 1, so we have 1n. I'm not going to write the 1 in front. 16 divided by 2 is equal to 8. So n equals 8 would be the solution for this equation. For number 11, we have 13 is equal to negative 4k plus 9. So this one might bother you a little bit because the variable's on the right side, but try to remember that it doesn't matter which side it's on. So let's start with undoing the addition that we see here. So the opposite of this plus 9 is going to be subtracting 9. So let's go ahead and do that to both sides of the equation. If we subtract 9 on both sides, on the left side, 13 minus 9 would equal 4. And on the right side, we just have this negative 4k. The plus 9 and minus 9 made 0, so we don't need to write that. So we really want 1k, not negative 4k. So we have this negative 4 multiplied by the k. So to get a 1 in front, let's divide it by negative 4, since we know negative 4 divided by negative 4 will equal positive 1. On the left side, 4 divided by negative 4 is negative 1. So we just have negative 1 is equal to positive 1k, or just k. K equals negative 1. For number 12, we have 7 minus 3y is equal to positive 34. And so we're going to try to get rid of this 7 that we see here first. If you're not sure what to do, just keep in mind that if you don't see a sign, it's a positive 7. So to get rid of it, what we're going to have to do is subtract 7 from both sides of the equation. Okay, so subtracting 7 from 7, that's going to be 0. We'll have 0 minus 3y. I'm just not going to write the 0. We'll just write the negative 3y is equal to, and 34 minus 7 is going to equal, I think, 27, right? Now, we're almost there. We have one more step. We have this negative 3 as a coefficient multiplying by the y, so we don't want that negative 3. We want a positive 1. So let's go ahead and divide both sides by negative 3. Negative 3 divided by negative 3 on the left side is positive 1, or just 1y. I'm not going to write the 1. And 27 divided by negative 3 is going to equal negative 9. So that would be the solution to this equation. For number 13, we have 9x plus 1 minus 7x minus 5 is equal to negative 20. So we just have to combine some like terms here before we do anything else. So on the left side, we have this 9x minus the 7x. So if you combine those, that should equal 2x, right? and then we go ahead and take a look at this positive 1 as a constant and this minus 5. So 1 minus 5 is going to be negative 4, so we can just write minus 4. And on the right side, we just have this negative 20 still over there, not really doing anything. Okay, so once you combine the like terms, what we have is a two-step equation again. So let's go ahead and see this minus 4. And to undo that, we're going to go ahead and add 4 to both sides of the equation. And so if we add 4 to both sides, that minus 4 and plus 4 will cancel out to make 0. So we have 2x plus 0, or just 2x. And on the right side, negative 20 plus 4 would equal negative 16 because it becomes a little less negative. So we want a coefficient for this x to be 1, so we have to get rid of this 2. And so to do that, we're going to divide by 2, since 2 divided by 2 is going to equal 1, or 1x. So we have x is equal to, and on the right side, negative 16 divided by 2 is equal to negative 8. That would be the solution for this equation. For number 14, we have our first equation with distributive property. So we have 91 is equal to negative 7 times the quantity of 3a minus 1. So when we see this, we're always going to start by distributing first. So this negative 7 times the 3a. On the left side, let's keep the 91. On the right side, negative 7 times positive 3 is going to equal negative 21. So we have negative 21a. And then going ahead and distributing this negative 7 to this negative 1, that's going to be negative 7 times negative 1, that's going to be positive 7. So now that we've distributed, we just have a two-step equation here. So just like earlier, we see this plus 7. Let's go ahead and do the opposite, or inverse, to get rid of it. Let's go ahead and subtract 7 from both sides of the equation. So on the left side, 91 minus that 7 is going to be, what, 84? And on the right side, we have negative 21a and plus 0, but we're not going to write the plus 0. So we want to get a alone, so we have this negative 21 as its coefficient, multiplying by it. So just like earlier, let's go ahead and divide both sides by negative 21. That's going to get us 1a. And so when we do that, 84 divided by negative 21, that should equal a negative 4. And negative 21 divided by negative 21 is just positive 1, or positive 1a. So we can say negative 4 is equal to a, or a is equal to negative 4. Either one is fine. For number 15, we have 4m minus 5 times the quantity of 3m plus 10 is equal to 126. So we have distributive property here, so we're going to start with that, since multiplication comes before combining like terms, which is addition and subtraction. So we have this 4m in front, and then a negative 5 times a positive 3 is going to be negative 15m. And then going ahead and distributing this negative 5 to this positive 10, negative 5 times positive 10 is going to be negative 50. Okay, and that's going to be equal to the 126 that we had to the right side. Next, before we make this a two-step equation, what we're going to have to do is combine these like terms of 4m and minus 15m. So 4 minus 15, that's the same thing as 15 minus 4, just throw a negative on it. So we'll have negative 11m minus 50 is equal to 126. So now we have a two-step equation, and we really want to get rid of this minus 50 first. So the opposite of that is going to be to add 50 to the left side, and then we'll add 50 to the right using that addition property of equality. And then on the left side, we have negative 11m. That positive and negative 50 will cancel out, and on the right side, 126 plus 50 is going to equal positive 176. So we have a one-step equation now, and we want to get this m alone, so this negative 11 that's multiplying by it, let's go ahead and divide by negative 11 using the division property of equality. And so we'll have positive 1m, or just m, is equal to 176 divided by negative 11. I think that should be negative 16. There's our solution. For number 17, we have 20 equals 10 minus 6 times the quantity of 2x plus 5. So again, before we try to combine like terms, let's go ahead and distribute first. That's going to take precedence each time. So let's copy down some of the stuff that we just need for later. 20 equals 10x. And distributing this negative 6 to the positive 2x, negative 6 times positive 2 is going to be a negative 12x. And then taking this negative 6 and distributing to this positive 5, 6 times 5 is 30. This should be a negative 30. Okay. The left side can't be simplified or combine any like terms, but the right side has this 10x minus the 12x. So 10 minus 12, well, 12 minus 10 is 2, so 10 minus 12 must be negative 2. So we have 20 is equal to negative 2x minus 30. So hopefully now you see this is a two-step equation, and to isolate x, we'll have to get rid of this minus 30 first. That's on the right. and go ahead and add 30, because that's going to be the opposite. And we'll do that to the left side to be consistent and be fair to both sides of the equation. On the left side, 20 plus 30 is going to equal 50. And on the right side, we have this negative 2x plus 0, but I won't write that plus 0. Okay. We want x alone, so we have this negative 2 as a coefficient multiplying by it. So to undo that or get rid of it, let's divide both sides by negative 2. On the left, 50 divided by 2 is 25, so 50 divided by negative 2 is negative 25. And on the right side, negative 2 divided by negative 2 is going to be positive 1, or just 1x. So we have x equals negative 25. For number 16, we have negative 3 times the quantity of k minus 8 minus the quantity of k plus 5 is equal to 23. So it looks like we're going to have to distribute twice here. Let's keep in mind there's some numbers here that might help us out. So keep in mind there's a coefficient of 1 here, so it's 1k. There's actually a 1k over here to the right. And there's also going to be a 1 or a negative 1 right in front of this parentheses. So those ones might help you out in terms of knowing what to distribute or what to multiply. So to begin, this negative 3 times positive 1, that's going to be negative 3 or negative 3k. Then going ahead and distributing this negative 3 to this negative 8, that's going to be a positive 24, so we're at plus 24. Following that, we're going to distribute a negative 1 to a positive 1. That's going to equal negative 1 or negative k. Then we'll distribute this negative 1 to this positive 5, and that's going to be a negative 5 or minus 5. That's all going to equal 23 on the right side. Once we distribute, we can try to combine like terms. So we have this negative 3k and this negative k or negative 1k. So negative 3k minus 1k, that's going to be negative 3 plus negative 1, or keep change flip or add the opposite. That should be negative 4k. And let's see, we can also combine some like terms here of positive 24, that constant, minus 5, another constant, that's going to be positive 19. And that's going to equal positive 23 along the right side. So we have a two-step equation now, and we see this plus 19. We want to get rid of it, so let's go ahead and move it to the other side by subtracting 19 from both sides of the equation. When we go ahead and do that, we're left with negative 4k is equal to 23 minus 19 is equal to positive 4, so we go ahead and write that. And so we have this negative 4 multiplied by k on the left. Let's go ahead and get rid of it and make a positive 1 by dividing both sides by negative 4. And we'll get 1k, or just k, is equal to, and positive 4 divided by negative 4 is equal to negative 1. That would be our solution here. For number 17, we have 20 equals 10x minus 6 times the quantity of 2x plus 5. So let's go ahead and distribute this negative 6 to this 2. And if we do that, let's copy down the 20 over here to the left, copy the 10x, and then negative 6 times positive 2 is going to be negative 12. So we have negative 12x. And then we have this negative 6 times a positive 5. That should equal negative 30. So go ahead and write that over here. Now that we've distributed, we can try to combine like terms. This 10x minus 12, that's going to be negative 2. So we have 20 is equal to negative 2x minus 30. And at this point, we just have a two-step equation. Hopefully that's starting to look a little more familiar. So to get x alone, let's go ahead and add or subtract first. Undo the order of operations, add and subtract, then multiply or divide. Go ahead and add 30 to both sides of the equation. Okay, we have 20 plus 30 on the left, that's going to equal positive 50. On the right side, we just have negative 2x. Okay, and so we want to get x alone, so we have this negative 2 as a coefficient, and so to get rid of it, let's go ahead and divide both sides by negative 2. Okay, 50 divided by negative 2 is going to be negative 25 along the left. And that negative 2 divided by negative 2 is just going to be positive 1, or just 1x. X equals negative 25 here. So for number 18, we have our first equation that has variables on both sides of the equation. It's actually not too complicated. You just have to move all the variable terms to one side and all the constant terms or regular numbers to the other side. So what I want to do here is, my preference is to start by moving this positive 3y to the left side. So I'm going to subtract 3y. And I'm going to take that away from a like term, which is going to be that positive 5y. Again, you don't have to start with that, but that's just what I'm choosing to do. Okay, I like my variables on the left. So 5y minus the 3y is going to be positive 2y, and you still have minus 8 equals, we have no more y's on the right side, so we just have 12. Okay. At this point, this is a two-step equation again. Okay, so it's just one added step that's a little bit different. We want y alone, so let's undo this minus 8 by adding 8 to both sides of the equation. Let's move it to the right side. And so we go ahead and add 8. We're left with 2y on the left equals, and 12 plus 8 is equal to 20. We want y alone, so this 2 that's multiplying by it, let's get the coefficient to be 1 by dividing both sides by 2. So 2 divided by 2 is 1, so we just have y is equal to 10. That would be our solution here. For 19, we have negative 6x plus 14 is equal to 12 minus 8x. So notice how we have variables on both sides of the equation now. Again, it's up to you where you want to put your variables, either the left or the right. I like them on the left, so again, let's take this minus 8x we see on the right side, and to move it over to the left, we can add 8x. And if we do that on the right, we should add 8x to the left side as well. So if you wanted your variables on the right side, you could add 6x, but this is what I'm going to do. On the left, this negative 6 plus 8, that should equal positive 2. It's just 8 minus 6. So that's going to be a positive 2x plus 14 is just equal to 12 on the right. There's no more x's. So again, this is just a two-step equation now. So to solve for x, let's go ahead and take this plus 14 and try to move it to the right side by subtracting 14 from both sides of the equation. If we go ahead and do that, this 2x is going to be left on the left side. And on the right side, 12 minus 14, that's going to be negative 2. Okay. To get this x alone, this 2 that's being multiplied by it, let's divide it to get a coefficient of 1. We always want 1. And so we get 1x, or just x, is equal to, and on the right side, negative 2 divided by positive 2 is equal to negative 1. There's our solution. For question 20, we have 7k is equal to 3k minus 36. So let's go ahead and move the variables to the left side again. So we have this positive 3k. Again, it's a positive because you don't see a sign. Let's go ahead and subtract 3k from the right and subtract 3k from the left. If we go ahead and do so, that 7k minus 3k is going to equal 4k. And on the right side, we have this negative 36. Don't forget that minus sign. Okay. We want k alone, so this 4 that's in front, that's multiplying. Let's go ahead and divide by 4, so we get a coefficient of 1. And so if we do that, we're going to get 1k, or just k, is equal to, and 36 divided by 4 is equal to 9. So negative 36 divided by 4 is equal to negative 9. Okay. There's our solution to this equation. For 21, we have 12 minus 2u is equal to 9u plus 45. And so I'm going to go ahead and start by getting our variable terms to the same side. So I'm going to move them to the left. So this positive 9u, let's go ahead and subtract 9u from both sides of the equation. Again, you could totally add 2u to both sides if you want to move it to the right side, but I like them on the left. So we have 12, and then let's see, negative 2 minus 9 is the same thing as negative 2 plus negative 9. So that's going to be more negative, or negative 11u. There's no more u's on the right side, and we're left with positive 45 on the right side. Okay. At this point, we just have a two-step equation, and to solve for u, we need to start by getting rid of this positive 12 that's on the same side of it, and we can do so by subtracting 12 on the left and subtracting 12 on the right. On the left, 12 minus 12 is 0, so we just have negative 11u on the left side. And on the right side, 45 minus 12 is going to equal positive 33. We want u alone, so let's go ahead and get the coefficient to be a nice positive 1. We can do that by dividing both sides by negative 11. So negative 11 divided by negative 11 is positive 1, or positive 1u. And on the right side, 33 divided by negative 11 is going to equal negative 3. There's our solution. For 22, we have 11 minus m is equal to 51 minus 6m. So again, let's move our variables to the left side here. So this minus 6m, let's move it over by adding it to both sides of the equation. Okay, so we go ahead and do so, and we should have this 11 on the left. And then we have this, technically this is a negative 1m, right? So negative 1 plus 6, the same thing as just 6 minus 1. That's going to equal positive 5m. And on the right side, we have this positive 51. There's no more m's on the right side. So here we have a two-step equation. This 11 we see on the left side is a positive 11. Let's go ahead and move it to the right side by subtracting 11 from both sides. So 11 minus 11 is going to be 0 along the left. So we have a positive 5m, or just 5m, is equal to, and 51 minus 11 is going to equal 40. So on the left side, we have this 5 times m, so let's go ahead and divide both sides by 5 to get a coefficient of 1. If we do that, we get positive 1m, or just m is equal to, and 40 divided by 5 is equal to positive 8. So m equals positive 8. For 23, we have negative 10k plus 1 is equal to 40 minus 7k. To begin here, let's take a look at this minus 7k on the right. Let's move it over to the left side. I'm going to add 7k to the right side and then add 7k to the left side. Okay, let's go ahead and see what happens. On the left, negative 10 plus 7, that's getting closer to 0, should be negative 3k. Okay, plus 1 is equal to, and we just have 40 along the right side. And now we have a two-step equation, so let's get k alone. So let's get rid of this plus 1 first. Let's move it to the right side by taking away 1 from both sides. And so we have negative 3k is equal to positive 39. And to get this k to have a coefficient of 1, let's go ahead and divide both sides by negative 3. So we get positive 1k, or just k, is equal to 39 divided by negative 3 is going to equal negative 13. There's our solution. For 24, we have negative 4 times the quantity of 2x plus 1 is equal to negative 8x minus 2. So hopefully you're starting to see we're putting the pieces together. We still have variables on both sides of the equation, but now we have to distribute first. So this negative 4 times this positive 2, that's going to equal negative 8, or negative 8x. And then distributing this negative 4 over to this positive 1, that's going to equal negative 4. So we'll write minus 4. And that's going to equal negative 8x minus 2. So you might see something interesting going on here, but if you don't, I'll show you in just a moment or tell you about it. So we have variables on both sides. Let's take a look at this minus 8x along the right and add 8x to the right side and add 8x to the left side. You might see it here. And so on the left side, negative 8x plus 8x cancels out to make 0, so we just have negative 4. And on the right side, we have no more x's as well, and that's just saying equals negative 2. So this is pretty interesting here because we said negative 4 is equal to negative 2, and this simply is not true. So whenever you get a solution that looks like this, where you get a statement that simply isn't true, you can go ahead and say that there is no solution, all right? This happens sometimes when you have variables on both sides of the equation, where you have an equation and there's no possible value that could make it true. So in this case, negative 4 does not equal negative 2, so there's no solution. If you get something like negative 4 equals negative 4 at the end, that means that any value would make this solution or make the equation true. So just be on the lookout for that. We may see a couple more coming up. For number 25, we have negative 5 minus 9x is equal to 3 times the quantity of 1 minus 3x. So to begin here, let's go ahead and distribute this 3 to this 1. If we do so, we get negative 5 minus 9x along the left is equal to a positive 3. And distributing this positive 3 to this negative 3x, that should be equal to negative 9x. And we still have this minus 8 that's hanging out over here to the right. Going in and combining like terms, we can't combine on the left, so on the right side we can. We have negative 5 minus 9x along the left is equal to 3 minus 8 is equal to negative 5. And then we still have this minus 9x. Okay, so as usual, let's go ahead and move all our variables to the left. So we have this minus 9x over to the right. We're going to add 9x, and let's add 9x to the left side as well. And so if we go ahead and do that, all the x's on the right will cancel out. We have negative 5, but also the 9x's cancel out on the left side. So we have negative 5 is equal to negative 5. So while in the last equation we got something that wasn't true, in this one we have something that is true. So as I mentioned earlier, when you get this scenario where you get a true statement at the end, you can say that x is equal to all real numbers. It means that any number, any real number that you choose for the value of x and you substitute it into the equation, it's going to be true since the left side and the right side are identical to each other. They were just written a little bit differently, so we just had to identify that. For 26, we have 3 times the quantity of 2x plus 2 minus 3x is equal to 6 plus 3x. So the first thing we're going to do here is distribute this positive 3 to the positive 2. That's going to be positive 6x. Then distributing this positive 3 to this positive 2, that's going to just equal positive 6. And then we still have a minus 3x on the left side of the equation is equal to 6 plus 3x. Okay. On the left side, we can go ahead and combine these like terms of 6x minus 3x. That's going to be positive 3x. and we have plus 6 is equal to 6 plus 3x. Okay, this is looking pretty interesting as well. We can go ahead and take this 3x that's along the right side, and let's move it to the left by subtracting 3x. Subtracting 3x again on the left side, just to be fair to both sides. And what you're going to see is the x's will cancel out, so we just have 6 is equal to 6. So just like the number 25, we get another true statement. So we can say here that, again, x equals all real numbers. Technically, both sides of the equations were identical, so anything you put in for x will work on the left side, matching the right side. For 27, we have 6 times the quantity of 2x minus 6 is equal to negative 7 times the quantity of negative 2x plus 4. So the first thing we're going to do is distribute, so 6 times 2, that's going to equal 12, or 12x. And then this 6 times negative 6 here is going to equal negative 36, so go ahead and write that. And then on the right side, we have this negative 7 times negative 2, that's going to equal positive 14, or positive 14x. And distributing this negative 7 to this positive 24, that's going to equal negative 28. Okay. Next, what we're going to do is get the variables to the left side. So we have this positive 14x on the right. To get that to the left, I'm going to subtract 14x and subtract 14x. Okay. And if we do that to both sides of the equation, on the left, 12x minus 14x, it's going to be negative 2x, and we still have minus 36. And on the right side, we still have this negative 28. Now, this is just a two-step equation, so we have this minus 36, and let's go ahead and add 36 to the left side, and we're going to go ahead and add 36 to the right side as well. And if we do that, this negative 2x is left on the left side, and on the right side, negative 28 plus 36 is going to equal positive 8. Next, we want x alone, so we have this negative 2 as a coefficient. We can divide by negative 2 and divide by negative 2 on the right side, so we get 1x, or just x, equals negative 4. That would be the solution here. For number 28, we have 8 times the quantity of 5x minus 3 is equal to 6 times the quantity of negative 3x minus 4. So the first thing we'll do is distribute this 8 to this 5x. 8 times 5 is 40, so we can write positive 40x. And then positive 8 times negative 3 is going to equal negative 24, so we can write minus 24. And then on the right side, we have to distribute as well, so 6 times negative 3 is going to be negative 18. So we have negative 18x. And we also have this 6 times this negative 4, and that's going to equal negative 24. Okay, so we have variables on both sides. Let's try to get them to the same side on the left. To get all the variables to the left side of the equation, let's take this negative 18x and add 18x to the right side, and let's go ahead and do that to the left side as well. So we go ahead and see what's 40 plus 18 on the left. That should equal 58. 58x minus 24 is equal to negative 24. Okay, and now we have a two-step equation, so we see this minus 24 on the left. Let's go ahead and add 24. If we do that on the left, we should do it on the right as well. And so we see what's going to happen here. The 58x is still along the left side. The negative 24 and positive 24 actually cancel out on both sides of the equation, so it equals 0. So this is actually a little bit easier for us. So we have 58 as the coefficient. Let's divide by it so that we get a coefficient of 1, as we have with every single equation. And so we just have 1x along the left, or just x, and 0 divided by 58 is equal to 0. So the only number that makes this equation true is when x is equal to 0. For 29, we have 3x minus 13 is equal to 7 times the quantity of x plus 2 minus 4 times the quantity of x minus 7. So just to get started, I'm going to write ones here just so it helps you see that we're going to be distributing and multiplying by 1. So the left side can't really be simplified at all, so we just have this 3x minus 13. Just leave that alone for now. On the right side, 7 times this positive 1x is going to be positive 7x. And then this positive 7 times this positive 2 is going to equal positive 14. Then distributing this negative 4 to the positive 1, that's going to equal negative 4x. And then multiplying this negative 4 times this negative 7 is going to equal a positive 28. Okay, so taking care of distribution, then we have to take a look at combining some like terms. The left side has none. But on the right side, let's see here, we have positive 7x minus 4x. 7 minus 4 is 3, so we can write positive 3x. and then we have a constant of positive 14 and positive 28. Combining those, that should equal positive 42. So now we have an equation that has variables on both sides. Let's try to get the variables to the left. So taking this 3x, let's take away 3x, and we're going to do that to the left side as well. Interesting, something might happen that we talked about earlier. And so 3x minus 3x is 0, so we're just left with negative 13 along the left side. And on the right side, we have just a positive 42 left. So this can't be true, right? Negative 13 doesn't equal positive 42. So for this equation, again, we're going to say that there is no solution. Okay? There's no value for x that can make this equation true. For question 30, we have our first equation that's a proportion, or a fraction equal to a fraction, or ratio equal to a ratio. And what you can do to go ahead and solve these types of equations is, there's many ways to do it, but I'm just going to show you cross products in this video. So what you do is, every single time you have these, you can multiply the cross product. So we can say here that 3 times x, or the product of those, 3 times x, that's going to be equal to 3x. And that always has to be equal to the product of the other cross products. So 6 times 4 is going to equal 24. So you can always just go ahead and multiply those diagonals, and it becomes, here in this case, a one-step equation. So to get x alone, we have this 3. Let's go ahead and divide both sides by 3. And if we do that, we just get 1x, or x, and that's going to equal positive 8. There's our solution. For question 31, we have another proportion here. So the first thing we can do, I like starting multiplying by the ones that has the variable. So let's multiply 2 times this n plus 5. And keep in mind that this really is going to be written like this. So you have 2 times the quantity of n plus 5. Just keep in mind that it's grouped together. And that's going to be equal to the product of the other diagonal. So that's going to be 10 times 4. And I'm just going to go ahead and write 40 for now. I'm going to skip writing out anything else there. First thing we're going to do is distribute, though, 2 times this 1n, that should just be 2n. And then distributing this 2 to this positive 5, that's going to equal positive 10, and that's equal to positive 40. So we have a two-step equation here, and we have this plus 10. Let's go ahead and subtract 10 from the left and subtract 10 from the right. If we do so there, we get 2n is equal to positive 30. And we see this 2 multiplied by the n. We can divide by 2 and divide by 2. And so we can say n is equal to positive 15. There's our solution. For number 32, we have another proportion here, but you're going to notice that both of the cross products are going to have a y in it, so it doesn't really matter what you start with. For this first one, 2 times y, that's just going to equal 2y. And for the other diagonal, we have this 5 times the y minus 3, or the quantity of it. So we're going to write 5 times, and use parentheses, y minus 3. So just be careful, make sure you put those parentheses in because we have to distribute. So there's a 1 in front of this y, that's its coefficient. 5 times the 1y is going to be 5y, so we have 5y there. And then this positive 5 times negative 3 is going to be negative 15. Here we have a two-step equation. We have variables on both sides, so we have this positive 5y on the right. Let's take it away from the right side and move it to the left side, just to combine those like terms. Okay, so 2 minus 5 on the left is going to be negative 3, or negative 3y. And on the right side, we're just left with negative 15. To get this y alone, let's take care of this negative 3 as a coefficient and divide by negative 3 and divide by negative 3. So we get 1y, or positive y, is equal to positive 5. There's our solution. For 33, here's another proportion, and it looks like we have variables on both cross products. I'm going to start with this diagonal here, so 3 times the quantity of this k plus 9. And then if we go ahead and multiply the other cross products, multiplying this 5 times this 2k minus 3, we can write 5 times the quantity of this 2k minus 3. Next, hopefully it makes sense, we're going to go ahead and distribute. This is a positive 1k, so 3 times 1, that's just going to be 3. Or 3k. Then we have this 3 times this 9, that's going to equal 27, so we can write plus 27. Then on the right side of the equation, let's distribute again. 5 times this 2k is going to be positive 10k, and then distributing this positive 5 to this negative 3, that's going to be negative 15. Okay, so here we have an equation with variables on both sides. I want to combine them and move them to the same side, so let's take away 10k on the right and then take away 10k along the left. So we have 3k minus 10k, that's going to be negative 7k, plus 27 is equal to negative 15. And to get this k alone, we take a look at this plus 27, and let's go ahead and take away 27 on the left and take away 27 along the right. And if we do that, we have negative 7k, and that's going to be equal to negative 42. That seems right. Again, a negative minus a positive, do keep change change or keep change flip, and add the opposite. So we're almost there. It's a one-step equation. We have negative 7 times k. Let's divide by negative 7 to just get 1k. And so we just get 1k, or k is equal to, and negative 42 divided by negative 7 is equal to a positive 6. There's our solution. For 34, here's another proportion. So we multiply this 8 times x. We can go ahead and just say that's going to be 8x. And then we can go ahead and multiply this diagonal here. So 3 times that x plus 10, that's going to be 3 times the quantity of x plus 10. So there's our equation without using fractions. Nice to just be able to know how to do that so that we don't have to use fractions. 3 times this 1x is going to be 3x, so we have 8x is equal to 3x. And then multiplying this 3 times positive 10, that's just going to be a positive 30. Here's an equation with variables on both sides. Let's combine those terms. We can subtract 3x from the right. Let's move it to the left side by subtracting. And 8 minus 3 should equal 5. So we have 5x equals, and that should be positive 30 along the right side. And now this 5 that's multiplying by the x, let's go ahead and get rid of it by dividing by 5 and doing it to the right side as well. So we just get 1x, or just x, is equal to positive 6. There's our solution. For 35, we have another proportion. We have variables on both sides, or both top and bottom. So let's going to start over here. Doesn't really matter. So 3 times the quantity of this p plus 7. And that's going to be equal to the product of 6 times this p plus 2. So I'm going to write 6 times that p plus 2. Okay. Going ahead and distributing 3 times this 1p. 3 times 1 is going to be 3, so we have 3p. And then 3 times this positive 7 is going to be positive 21, so we can write plus 21. And then to the right, 6 times this 1p, that's just going to be 6p. So we can write 6p here. And then 6 times this positive 2, that's going to be equal to positive 12. Let's go ahead and get the variables to the same side. So take this 6p and take away 6p. Let's do it to both sides of the equation here. So 3 minus 6 on the left is going to equal negative 3p plus 21, and that's going to equal positive 12 along the right. And then we have a two-step equation here. Let's take away 21 from the left and take away 21 from the right. If we do that, we should have negative 3p is equal to negative 9. And to get this p alone, let's get rid of this negative 3 by dividing by negative 3 on both sides. We get 1p, or p is equal to positive 3. There's our solution. For 36, another proportion. Let's start by multiplying 3 and w together. Those will multiply to get 3w. And then going ahead and multiplying 6 times this w minus 2, we're just going to get 6 times the quantity of w minus 2. Okay. Going ahead and distributing this 6 to this 1w, we can write as our next line 3w is equal to 6w, and we distribute the 6 to the negative 2. 6 times 2 is 12, but it's a negative 2, so it's going to be minus 12. So here we have a two-step equation with variables on both sides. Let's take this 6w and move it to the left side to combine it with the 3w that's already there. 3 minus 6 is equal to negative 3, so we have negative 3w is equal to negative 12. And to get this w alone, let's take this negative 3 and divide it on both sides. So we get positive 1w, or w, and that's going to equal positive 4. There's our solution. For 37, we have yet another proportion. I'm going to decide to multiply these first. So we'll have 6 being multiplied by this n minus 7. And then we have this 9 being multiplied by the n minus 4. So we have 9 times the quantity of n minus 4. Okay, let's go ahead and distribute this 6 times this 1n, and then the 6 times negative 7. Let's do those both together now. finishing up, so 6n minus 42. And then let's go ahead and take this 9 and distribute it. And we'll do both of them together as well as you get the hang of it. 9 times 1 is 9n, and then 9 times negative 4 is negative 36. So we have variables on both sides. Let's take this 9n and take away 9n on the right and take away 9n along the left. If we go ahead and do so, 6 minus 9 is negative 3, so negative 3n minus 42 is equal to negative 36. And then we have a two-step equation now, so let's take this negative 42 and add 42 to the left and add 42 to the right. If we go ahead and do so, we just have negative 3n is equal to, let's see, what is that, positive 6? Seems right. And we want n alone, so let's take this negative 3 and let's divide both sides by negative 3. So we're going to get positive 1n, or n equals negative 2. There's our solution. For number 38, we have another proportion here, and we can use cross products again. So going ahead and multiplying these diagonals, we can go ahead and write 3 times the quantity of a plus 1 is equal to 2 times the quantity of a minus 3. Going ahead and distributing this 3 to this 1a, or 3 times 1a, and 3 times this positive 1, and multiplying this 2 times this 1a, and then 2 times this negative 3, we can go ahead and write 3a plus 3 is equal to 2a minus 6. We have an equation here with variables on both sides, so again, like earlier, I'm going to go ahead and take away 2a from both sides so that we get all the variable terms to the left side of the equation. So if we do that, 3a minus the 2a is just going to be 1a, or a, plus 3, and that's going to be equal to negative 6 on the right side. Now, to get this a completely alone, we have this plus 3 going on here. We can go ahead and subtract 3 from the left side and then subtract 3 from the right side. And if we do that here, we're just going to be left with a on the left side, and on the right side, negative 6 minus 3, or negative 6 plus negative 3, is equal to negative 9. There's our solution. And finally, for question 39, we have one final proportion, and we can use cross products again to go ahead and solve it. So multiplying this 5 times the f plus 2, that's going to be 5 times the quantity of f plus 2. And on the right side, 25 times 3 is going to equal 75. We'll go ahead and distribute this 5 to this 1f and this 5 to this positive 2. 5 times the 1f is going to equal 5f, and 5 times positive 2 is going to equal positive 10, and that's equal to 75 on the right side. We just have a two-step equation here, so let's get rid of this plus 10 that we have on the left. By doing so, we can subtract 10 from both sides of the equation, and 10 minus 10 is going to equal 0, so we can go ahead and write 5f is equal to 65 on the right side. That's 75 minus 10. And to get a coefficient of just 1, or 1f, let's go ahead and divide both sides by 5 here. So we just get 1f on the left side, or f, and 65 divided by 5 on the right side is equal to 13. There's our solution. And that just about wraps up 39 different examples on solving different types of equations with one variable. In summary, in this video we practiced solving one-step equations, two-step equations, equations with variables on both sides, equations with distributive property and combining like terms, as well as solving equations that had fractions, also known as proportions. If you found this video helpful, you can let me know in the comment section down below or by giving the video a thumbs up. And as always, keep up the great work, and I'll see you in the next one.